impedance usually we play until 600 kilowatt lah. Usually they will bypass slightly faster compared with the timing. Unless there's heavy starting load, like a compressor. Usually they take about 10 to 20 seconds to ramp up. Then the peak current can be 400. They will maintain at 400% for about 20 seconds. But that one is different calculation. This is not class 10 production. Last time I did is class 20. Okay, so they will maintain at 400% for about 20 seconds. When they detect falling edge, then only the contactor will kick in and bypass it. Then the thyristor will kick off. At that moment, thyristor will kick off.
Oh, that kick off.
Thyristor kick off. If you look at the circuit, got the circuit?
Thyristor?
No, the wiring circuit. They show the thyristor, right? See, jangan get sorry. Cable too small. Cable too short. You've got the soft starter circuit. Okay, look at this. Okay, here you see, there is a, they only mentioned 1252. So basically in soft starter we got 20 series, 30 series, 40 series, 50 series.
Yeah, that's all this now.
Yes, okay, if you look at this is a thyristor. But usually you have a bypass circuit. Okay, this is not the conventional starter. Conventional soft starter. This is the basic soft starter. You need external bypass circuit. Basically, this is already built in one unit. The entire thing already, we don't need any external contactor for the bypassing. Mostly in the market, 99% soft starter always come with a bypass contactor built in. It's either there's a two-phase control or three-phase control. This is three-phase. For small one, where is it? That one mainly is a 30 series and 40 series. 30 series, 40 series about this size. Small. Okay, that one usually is two-phase control for low-end application. So, if two-phase control means one of the phase always left. Okay, so to prevent any accident, we put a contactor after. Yeah, it's still possible to do it. This is one of the common design we always use at. We saw at the customer panel. Usually we use hybrid one easier. Okay, so this model basically is a 30 series, 3W30 and 3W40. The shape is something like that, but don't have this. Where you get this over?
Huh?
Where you get this?
You check.
Real pulse.
Real pulse. Okay, real pulse. They just explain the circuit. Basically, this is already built in.
Even yang 300 pun dia 3
yes, 3W30 series, 40 series.
Ada built-in.
Mostly, very difficult to find a soft starter without a bypass contactor.
Okay.
Very sudden. There's another design we call inside delta circuit, but that one is high for the high-end soft starter. Soft starter also very big, very long character, I can tell you. Okay, so for a concept, this entire thing actually already built in. Means there is a thermal overload, there is a thyristor circuit, there is a bypass contactor circuit. Everything built in one unit. Okay, you look at this very big one. Actually, inside already everything. There's a circuit here. If you notice, see there is a bypass contact inside. Standalone contact. Okay, there is a bypass contactor built in. Okay, so just now what you've seen just now, the bypass circuit. Try to start. Yeah, immediate bypass. Basically because there's few reasons. One, the motor is too small. Second, the motor no load. Okay, if you look at this, they've shown the amp how many amps? I couldn't see from my side.
How many amps?
How many amps? The amp very 1 amp, 1 point something. 4 amps, right? But the actual is 0.2 or 0.3, 0.4 only. Less than 1 amp. But this is the modified unit. Modified unit. That's why I put some instruction notes over there. Okay, this is the modified unit. We purposely modified for demo purpose only. Okay? Continue.
I think dah habis lah untuk
Habis ya? Betul betul.
I think you boleh teruskan untuk VFD. It's better lah untuk semua orang boleh faham.
Okay, so for soft starter, I let's your mouse.
You nak kena buka you punya
I tengok apa lagi you punya soft starter.
Tak ada pun, dah basic je.
Habis.
Tu ya? Tu ya? Simple betul ni.
Dah mention untuk
Okay.
simple je.
So for soft starter lah, for your basic understanding lah, basically soft starter, there's another big soft starter. This is called 3W44.
Belakang ada kan?
Ini dah obsolete lah. Basically this is the replacement model 52 dengan 55. Mana ni minimum?
Ada.
Kita workshop kot. Okay. There's a two model. Okay, this one is a basic model. Basic model. So everything controlled by the dial. Okay, you have to follow the table to set the current, set the class protection. You can explain the class,
Yeah.
motor class.
Belum. Itu I tak tahu nak explain macam mana.
Okay, so basically, okay, for there's a fundamental lah. For motor class protection, when you talk about motor overload protection, we always refer with the IC class. Okay, so the IC 61045, I can't remember the code already. Something like that. There is an IC standard curve. The IC curve for motor class protection. So common in the market always we use a class 10 protection, class 10A. Another, the new standard we call class 10E. Class 10 protection, standard. Okay, so the class number, highest the number, lagi lama dia boleh tahan, dia boleh overload. Lagi lambat dia trip. Lagi kecil lagi cepat. Tapi bawah 10 5 je. 5, 10, 15, 20, 25, 30. Kelas 40. Tapi jarang sampai kelas 40. Paling besar pendengar kelas 20. Itu biasa centrifuge, compressor, especially centrifuge. Centrifuge memang dia start current tinggi gila. So centrifuge, if you laboratory usually you see the centrifuge is a very small one, tiny one with a very high power, they rotate, right? But in industrial, the centrifuge motor sometimes 100 kilowatt, 200 kilowatts. The size about this up maybe, about yang tong sampah tu, satu lah. In the horizontal lah. If you feel 100 kilowatts about this size.
Besar.
Kalau paling besar paling sampai megawatt. Kalau megawatt tu memang besar satu kancil motor.
Motor satu kancil.
Satu kancil. Lebih kurang lah. Tapi depend application. So if we imagine if a centrifuge about this size, the motor about this size, the thing that driving this side, these are driving something. Okay, so maybe the centrifuge about this big, this paper big. How heavy is that? So the start current memang tinggi lah, sampai beribu-ribu lah. Okay, so okay, for conventional, usually when we talk about starter basically there is a steps from DOL until soft starter. Okay, so that one you can cover. Fundamental. Okay, so basically DOL is the most low end one, also is a more basic, more direct control. Okay, from DOL, next level we go to the start data. So start data basically is to control the motor start up with a start followed with delta to reduce the peak current. How much is peak current? Usually
70. 70 30.
No. The voltage is about 50-100. But if we talk about the overload about 7 to 10 times. Slightly lower than DOL, but still high. Then the third option, auto trans. The auto trans is the old technology. Okay. Then disadvantages of auto trans, you need a complicated circuit exactly the same like starter, and they will generate heat. Then your fan is not recommended to put it outdoor because they will generate heat. Then it's a coil, even though it's maintenance free, but they will overheating issue. Then next level soft starter. Soft starter is one of the best. They're using semiconductor control, power semiconductor control. Definitely the lowest current, the lowest start current compared with among all the starters. But the limitation also will be there lah, temperature lah. Always lah, and also it's not supported for frequency start application. High frequency start application because your dicer will heat up very fast. When you try to do a limiting, right, the start current it will cause the dicer heat up very fast. So usually for those applications require a frequent start, it's not recommended to use a starter. Okay, so next level of starter using inverter. Now we talk about inverter. Inverter is no longer under starter category. Okay, so if you look at Siemens one, if everything about motor control is related with series. Series basically is everything covered for motor control, including your button, contactor, MPCB, your source starter, even though your CMOS code, blah blah blah, everything under series use. Okay, when you talk about inverter is another topic. In Siemens, they call dynamics. Everything is dynamics. So before dynamic, we got another two, MicroMaster and CMOS, but both are oscillated. Now only have one, dynamics. Okay. So basically in dynamics, there's a three type of control in the market. Okay, there's a PWM control, CSI and VVI, but these two already obsolete. For the old type generation, maybe silver one still have, but new one we always use PWM. Okay, this is a variable voltage inverter and also it's a current source inverter. Basically the structure is slightly different. The concept wise is the same. Okay, this is the most basic one. They're using front and back both are using the rectifier circuit. There's no IGBT inside. Okay, and this one using IGBT, a bit same concept like this. But the VDI basically is a variable voltage. They just play around with the voltage without the power factor or something else. Okay, the size different. Okay, these two are already obsolete. Okay, now we only focus with this. So for inverter, we separate three portions. One, I explain this. You should explain this one. Everyone, you proceed first. I talk about it.
It's better you explain. Everyone can understand fast.
Never mind. You just proceed because it's part of your. At least you finish your presentation. I will talk up.
Okay.
And I will explain more on the software side because it's fundamental. I cover a few pages. Okay, so for inverter, not only Siemens, the whole all the brands is a common one. Every single inverter we're having a unified structure. Just the front part will be different. So for inverter we got three parts: converter part, receiving part, inverter part. Okay, so converter part basically do nothing. Straightforwardly convert AC to DC. Just like that. They are not doing error control. As long as you feed 415, you feed whatever voltage, I just invert it. How much the voltage you feed, then how much the DC I generate. Okay, so Siemens concept for Siemens one, standard conversion is 1.32 times. 1.32. So converter basically just a full bridge rectifier. They just convert the voltage from AC to DC. Do nothing. They are not monitoring whatever. Do nothing. Basically nothing. They just conversion of the voltage. Okay? So standard 415 voltage when you come in three phase, our DC link we measure about 560 VDC. Standard. But other brand almost the same. They might have different ratio. Like Eaton EF5 is taking 1.32. Siemens 1.35. ABB 1.2 something, I can't remember. But common only. Every single inverter having the same concept. Okay? Then we come into DC. DC link basically is a LC circuit. Inductor capacitor circuits. Okay? If you look at digital control, then you know what is LC circuit. Basically everything is LC circuit. L and C. Okay? Here is your cap bank. LC circuit basically is a cap bank. Capacitor bank.
Oh, that's it.
Capacitor bank. But commonly we call cap bank. Okay. Capacitor bank to store all the energies. And this is where the energy storage. Okay? So AC is unable to control. So we want to control, we have to control DC. Okay? So we need an inverter circuit. Invert from DC back to AC. This is where PWM looking. Okay, power electronic we have four. AC, DC, DC, basically this combine all four.
Oh.
DC don't have lah. DC certain application yes. Okay, this is the standard AC to AC inverter. In inverter we got AC DC inverter, DC AC inverter, and AC AC inverter. Very seldom for DC DC lah. But we still available for DCM. Actually there is a DC module, DC DC converter. In Siemens we got 4 types. But common we use the AC AC lah. Basically AC AC is combination AC DC DC AC, both combined. Okay, if you talk about AC DC without this. But they will replace this become IGBT. That one will be called DC5. Okay, but conceptually it's something like that. Okay, for certain high-end application, they will replace this converter become IGBT as well. So they provide another features we call power backgen. Mean when your motor try to slow down, there will become a generator. The backfeed energy is not only stored in the capacitor, they will backfeed to the power line for power saving. That one is a high-end inverter. That one is the S series. We talk about that one very further. Okay, we talk about fundamental first. So basically, you need to remember we have 3 sections: converter, DC, inverter. Straightforward. This is the fundamental. Okay. Here what we mentioned. Control require energy saving. Okay. Energy saving. Anything I didn't cover. Okay, so in the market, some people will call VSD, some people call VFD. Basically it's the same. Variable speed drive, variable frequency drive. At the end we still control flight frequency. Because PWM. Okay, so this is the principle of the operation. We convert from 3-phase input, become a DC bus, then PWM, output to the motor. So this is the curve we are going to read by the inverter. I read by the oscilloscope. Using oscilloscope, the curve is no longer side. We become PWM wave for the inverter. That's the reason why if you try to run the inverter with a motor, you heard a high frequency sound. Okay, so usually when you went to site, I heard the motor, I already know, okay, this is inverter duty or this is a normal duty, or normal starter duty. Okay, usually inverter they will have a sound. Same like aircon now. No, there's a high frequency, high peak sound. Okay, but we can tune the high peak sound until you can't hear. For certain inverter, but usually we are not going to tune it. Only for those like indoor application, then only we tune the inverter. Okay, this depends on